Hi, everybody. Thank you for coming to our talk. My name is Elizabeth Morrow, and I work for Microsoft's C++ Cloud and Cross-Platform team. This is Augustin.
Hello, my name is Augustin. I also work on the C++ team at Microsoft as a program manager.
So what we really want to talk to you today about is some of our favorite tools for C++ cross-platform development.
All right, so first of all, I guess let's get a show of hands. How many of you are writing code today that targets Linux? Okay, I see quite a few hands. What about Windows? Quite a lot of Windows as well, so pretty good split. Well, if we look at things more broadly, this is the ISO C++ 2019 developer survey. We can see, well, what are the platforms you develop for? We see close to 70% for Linux desktop, close to 70% for Windows desktop. Those two numbers add up to more than 100%, and you can multi-select answers for the question. So clearly there are some people that are doing more than one platform in this case. And even if we look at some of the other options like server and cloud, chances are you're running something that's Linux or Windows on that as well. So clearly there is a need in the community for targeting multiple platforms. So let's actually talk a little bit about this buzzword, cross-platform.
So when we are saying cross-platform, we really could mean one of two things. We could mean that you're writing code and that same code has to compile and run on multiple platforms. That could be Windows, that could be Linux, that could be Mac OS. And then the other definition that we're talking about when we talk about cross-platform is that you're writing code on one platform and you're leveraging dev tools from one platform, but you're actually building and running on another. And not to be confused with cross-targeting or cross-compilation, what we're talking about is the build tools actually running on a different machine.
Okay, so there are a lot of different tools that you can use for cross-platform development. We only have 45 minutes total, so we'll focus on a few tools. We'll mention a few of the other ones along the way as well. But the things we'll be talking about in this talk, we'll cover a variety of different areas. So first of all, in terms of the development environment you're working in, like your IDE or code editor, we're going to talk a little bit about the Visual Studio IDE and Visual Studio Code. We'll also talk a little bit about, okay, what about your project system, your build system? And we'll focus on CMake for that. Another common problem is dependency management. When you have a bunch of libraries that you're depending on for your application, in C++, it's an especially big problem. So we'll talk a little bit about Vcpkg, which can help with that. And also, for those of you who are on Windows today, but if you are thinking of targeting Linux, there is a nice, easy way of doing that, which Elizabeth will talk about with the Windows subsystem for Linux. All right, so starting off with CMake. So first of all, how many of you are already using CMake today, just to get a sense of things? Okay, so I see quite a few hands. All right, so CMake has definitely been growing a lot in popularity over the years. For those of you who don't know, it's an open source cross-platform. It's kind of like a project system managed by these CMake list.txt files, but it's also kind of like a meta build system. We add the word meta because it can invoke a variety of different build drivers behind the scenes. So things like MS build or make, or also something called Ninja, which is particularly high performant for getting your builds done really quickly. And all of that is something that CMake can do. And CMake is really ideal for writing cross-platform code, for writing open source code. And it's something that we at Microsoft in particular have been paying attention to a lot over the past couple of years. So with CMake, you kind of have a multi-step process that goes on. You have to generate a CMake cache. Basically, you're initializing your environment to actually invoke the build driver that actually does the builds behind the scenes. And then you actually do that part, and then the build happens. So we will talk about how that can work in two different development environments of VS and VS Code. But first, so I mentioned earlier, dependency management, common problem in C++, regardless of what platform you're on. If you have a more complex application and you're requiring some third-party libraries, there are a lot of popular open source options out there. but it can take some time to acquire them all and build them all in such a way that they all work together and they work with your application. So something that can make your life easier for that is a tool called Vcpkg. This is a tool our team maintains. It's open source, cross-platform. You can run it on Linux, Mac OS, or Windows. And it has over 1,200 libraries supported. So pretty much anything that's popular is probably on there. And the way it works is it actually builds from source. So rather than you downloading some pre-built binary that may or may not work with your particular application, you can invoke Vcpkg to install a set of libraries that conform to your build requirements. It does it all in one step, and then you can just start using them. And it integrates nicely with Visual Studio and Visual Studio Code as well. And one thing where we carefully curate the catalog of libraries, and we test them all against each other and try to make sure that they all work together. So whatever set of libraries you pick from the catalog, you can be reasonably confident that they will work out of the box without further changes. And there's a GitHub if you want to follow it or contribute. We're always looking for contributors. And so I guess the next thing to talk about is Visual Studio Code. So I think we asked earlier what platforms you are targeting, but here's another question. What platform are you actually doing your development work on? So how many of you are on Mac OS, doing development on Mac OS? So not necessarily targeting Mac OS, but you're on Mac OS. I don't see any hands. Oh,
There's
hands.
two.
There we go. 2 hands. Okay, so we have a few Mac OS developers. What about Linux? Few more hands. Okay, so then Windows. Quite a lot of hands. Wow. Okay. All right. So regardless of which of those platforms you're using, Visual Studio Code will work. So that's good news. It's actually as of a couple of years ago, it's the most popular code editor in the world according to Stack Overflow. And it does have a C++ extension, which adds a lot to it. A lot of people think Visual Studio Code is kind of a lightweight code editor, but you can actually do building and debugging, and you get auto completion and all kinds of advanced stuff in it as well. You might have to do a little bit of additional configuration to get the full experience, but it's highly extensible. And one of the things it actually has is a CMake tools extension, which we're now maintaining as well, which gives you a nice CMake project system support built right in. So I think the best way to actually show what I'm talking about, I'll actually go into a demo with Visual Studio Code. So let me open this up. All right, so what I have here is an application. It's a game. It's called Super Tux. It's a cross-platform application. You can build it for different platforms. And I have it up and running in Visual Studio Code. I did install the C++ extension for Visual Studio Code. Only takes a few seconds, really easy to do. Installed the CMake tools extension. Again, only takes a few seconds, really easy to do. And that adds a lot to my environment. So for example, I have semantic colorization backed by our IntelliSense compiler that helps you really understand and visualize your code. I have different features I can use. So for example, if I wanted to do find all references, over here, this will run our IntelliSense compiler behind the scenes. It'll look for anything called m_pause, and then it will check it against the compiler to make sure that it's the same and m_pause that I referenced here, because there may be multiple things with the same name that are completely unrelated in the code base, and this will actually go through and validate them. So it's a lot better than just doing like a text search, because a text search you're not guaranteed to get exactly that subset that you care about. So here I found a bunch of results, and I can explore basically all the different places that m_pause is used. But let's say I had something specific I wanted to do here. Let's say I actually wanted to go ahead and rename this symbol. So if I right-click it, rename symbol, that's an option, or I can press F2. I can type in a new name, so maybe I want it to be n_pause for some reason. So I could just press enter and rename everything. But let's say I want to be a bit more certain that things will actually work the way I thought it would. Oh, sorry about that. Just opened PowerShell for some reason. But trying to stretch over this keyboard. Let me do that again. So F2 rename and _pause. And then I can do Shift Enter. instead of enter. And this will actually kind of do something similar with find all references, where it will go in and run things with the compiler behind the scenes in real time and figure out, okay, what are all the references of m_pause that we could rename here? And it will go ahead and show them shortly. And then I can decide if I'm happy with this list and confirm that change. So it's as simple as that. Now, there are other features I can use for productivity in Visual Studio Code. For example, one of my favorites is peak definition, or Alt F12, which kind of opens like a pop-up here to see exactly where this floor F is actually declared. And there's other features like that that just save you a bunch of time. And if you've used Visual Studio before, these features certainly exist in Visual Studio as well, but they're also in Visual Studio Code, and we're continuing to add more productivity features to Visual Studio Code. So it's a lot more than just a code editor. It's really becoming more and more like an IDE. And while also being very lightweight and cross-platform, which is nice. Okay, so let's talk a little bit about the CMake stuff, because I did say I installed CMake tools, and this is a CMake project. So when you install the CMake tools, a few things will happen. First of all, if you look at the status bar at the bottom of the screen, I wonder if I can make this a little bigger, actually. Okay, hopefully that looks a little better. So if you look at the status bar at the bottom of the screen, there's a few things going on here. So first of all, here, if I click this, this is showing me a list of available kits. We call them kits. And essentially this is a list of available compilers and architectures that I can use. The first time you would open this, you would probably just see scan for kits as an option. You can click scan for kits. It will search your machine for common locations where compilers are installed. If you're on Linux, it'll search wherever your system package manager would install GCC. If you're on Windows, it'll search for where would Visual Studio install MSVC and any other compilers that you may be using. But you can also define your own kits if you're putting things in specific places or you're using some other compiler that's not one of the big three popular ones. You can go ahead and specify that. And the second thing that's happening here is I have a variant set, so we call them variants. This is like debug, release, and some other options that you can specify to determine how exactly you want this to, or how you want, like basically your build configuration. So right now I have it set to debug. I am setting it to build for x86, and we can see here, so SuperTux 2, this is the launch target. If I go to this tab here at the bottom, this is a CMake targets view. We have this in Visual Studio as well, but it's also in Visual Studio Code with this extension. It gives me a list of available CMake targets. Really the only one I care about is this one, SuperTux 2, and that's set as the launch target. And I also have it set here, the active target to build, I want everything to be built. And basically it's configured the way I want it to be configured. So I'll go ahead and actually, before I click build, I just want to show another thing that you would want to do. So if I press Control-Shift-P, that opens something called the command palette, and I have all of the basically commands available that I might be interested in. All right, so if I type in CMake, I see all of the available CMake commands, starting with recently used ones, because I was playing around with it before. But you can see here all the different things I can do with CMake. So normally, what I would do is I would do a CMake configure. And this will go ahead and generate the CMake cache, and hopefully nothing crashes really badly. But we can see here I've already done this before, and so I don't have to go and wait for the whole application to do it from scratch. And it went ahead and it finished generating, and it wrote some build files to a directory, and everything looks okay. So I'll just go ahead and now click build here at the bottom. And when I do this, it invokes Ninja. My build is up to date, so Ninja has no work to do. Exit code 0, everything looks good. So let's go to the next step, which is let's actually debug. And to debug, I can press it down here. But another thing I can do is I can actually go back to my targets view, right-click, and click debug on the target. And when I do that, it'll hit a breakpoint that I set at the start of the main function, and I can actually step through things and see what's going on. If you look on the left side, there's a call stack, and there are a bunch of variables and their current states that are being listed. It's using the Visual Studio debugger in Visual Studio Code, but this also works with LLDB on macOS. It works with GDB on Linux, and I can see the state of everything and step through it. And I can do all kinds of things if I want to. I can right-click and set a conditional breakpoint if I want to, just like I could in Visual Studio. I can run to a particular cursor if I want to, or jump to it if I want to just change the order that things happen in for some reason and just go against the execution flow of the program. I can do that too. So all of that just works out of the box. But if I just F5 to just run all the way through, I don't have any more breakpoints. It'll go ahead and actually open the game just to show you what this game actually is. It's pretty straightforward. You're controlling a penguin. It's kind of like one of those Mario games, really, and you just move around, and you can jump, and you collect coins, and try to jump on enemies, and hopefully not die like I just died, but I'm not very good at this game, clearly. So I'll just go ahead, close that down, and that's SuperTux running on Windows in Visual Studio Code with CMake. Now, I did say that Visual Studio Code is cross-platform, and this program is cross-platform. So, I mean, I should clearly prove that, right? So let me go ahead and actually connect to a VM I have running here. And it's going to go ahead and restore it. So this is running Ubuntu, and I also have this code base set up in Ubuntu pretty much the same way, with no real additional changes happening there. And if I click debug at the bottom, it should run the game. Now, if you look at the bottom as well, you'll see I'm using GCC this time on Linux, and it's actually using the GDB debugger behind the scenes. But the overall user interface is the same. And again, I hit the breakpoint, and if I F5, it'll be a bit slower because it's a VM, but it should open up the game. So there you go. Okay. So one other thing I actually did that I didn't touch on to set all this up is I actually used Vcpkg, both on the Windows side and on the Linux side. And it's really as simple as just running, switch here, Vcpkg install, and here's the list of all the dependencies that I care about. Unfortunately, it's a little small right now. I don't know if I can zoom in. Okay, Control Plus doesn't work on PowerShell, but basically what I have here is Vcpkg install, and there's a bunch of dependencies, Boost, a bunch of Boost libraries, curl, and a few other things. And I just type all that and then enter. Now, I already installed them beforehand, so we went ahead and checked the packages that are installed and determined everything's up to date, everything's good. And it installs everything, and it just works from that point. So I didn't have to go library by library, installing everything one by one, and hoping that it works and not having to go back and fix it later. So this is actually really useful when preparing demos. It saves a lot of time. But I think it's more useful more broadly. All right, so otherwise, let's actually switch back. Okay, so just quick summary. You can bring your own CMake project or start a new project with CMake in Visual Studio Code, Windows, Mac OS, or Linux, doesn't matter what your development environment is. Install the C++ and CMake tools extension. You get lots of productivity features, edit, build, debug on any OS. And there are a few other features I didn't have a chance to talk about, but that are worth looking at when you get the slides later on. You can actually target remote environments with Visual Studio Code now, so remote machines, containers, or the Windows subsystem for Linux. You can run your dev environment actually in the cloud. So if you want to run Visual Studio Code in the browser, that's something that's starting to become a thing. It's called Visual Studio Online, and it's not the same Visual Studio Online that we now call Azure DevOps. I don't know what happened with the naming there, but this is actually Visual Studio Online, and Visual Studio is also going to light up for this as well. But Visual Studio Code is already available for you to try out if you want to see that. And we're continuing to invest in the CMake tools extension. Multi-root workspaces and the file-based API are two new things here. So I'll go ahead and pass it on to Liz.
Thanks, Augustin. So something that Augustin called out as an option for another tool to use is the Windows subsystem for Linux. And so we saw a bunch of people who their dev box is Windows earlier. And if you want to try out developing for Linux, this is a really good option for you. So the Windows subsystem for Linux, or WSL, as we're going to call it from now on, it's a Windows 10 feature. It ships with Windows 10 and later builds. And it provides basically a native Linux command line utility so that you can use use with your Windows file system, or you can have an isolated Linux file system, all inside your Windows machine. And so what we see this used for, it's really developer focused, and what we see this used for a lot is using ecosystems that were really designed Linux first. And so that might be Ruby, that might be Python. A lot of it is web development centric. And so recently we announced at Build 2019 WSL2, which takes WSL1, which was working by having a translation layer that would translate POSIX calls to Windows calls, or Windows system calls. Now we have WSL2, which is actually running an isolated Linux kernel inside a lightweight Hyper-V VM. And so you actually have your Linux kernel running rather than just through this translation layer. And you still get all of the benefits of WSL1, which is that you can run all of your Linux tools on anything in your Windows file system because it's entirely visible to the command line tool. So this is a great tool if you want to try out getting into cross-platform development or developing for Linux. So we saw a bunch of Windows developers. Can I see a show of hands of people who've used Visual Studio before? Awesome, we love to see that. And now, how about people who have used Visual Studio with CMake? A lot less people. Well, let's see how to do that today. So a lot of you probably know that we have pretty great C++ tools inside Visual Studio, and it seems like a lot of you have used them. And now we support a really big range of cross-platform scenarios. And when we say cross-platform scenarios, what we really mean is having that dev inner loop, so editing your code, building your code, and debugging your code on Windows or on a Linux VM. And you can really bring your own tools to that situation, and you can also bring your own build system. So we provide first-class support for MS Build in those scenarios. Then we also provide first-class support for CMake in those scenarios. And for cross-platform development, we're really going to encourage people to use CMake because the build system itself is cross-platform, and we really don't want to tie you to an IDE. We really want you to be able to use whatever tools you want to work on your project. And so the way that this is working is that you add an SSH connection to your remote machine through Visual Studio, and then we can actually drive your build processes behind the scenes over the command line. And so we're using GCC, we're using GDB, we're just surfacing the information that we're getting from those tools through the Visual Studio interfaces. And we're going to get to see that, and we're also going to get to see our first-class CMake support. And so a little bit more background about how this remote targeting works is that the only things that we're actually keeping on your Windows machine are the things that are necessary to give you this full-fledged IntelliSense productivity experience in Visual Studio. So we've got the source files that you're editing, and every time you make a change to those, every time you want to run a build process, we run an incremental sync powered by rsync, which our Linux developers will be super familiar with. So we're only syncing over the files that you're changing to your remote system, and then we're keeping a synchronized source tree on that remote system so that when we're actually running your build tools, it's the same code that you're editing in Visual Studio. And so another thing that I really want to call out as being an awesome part of this remote experience is that using GDB on the command line can get a little bit tiresome, especially with big projects. And so leveraging the Visual Studio debugging interfaces and debugging tools, but backed by GDB, is really, really powerful. And another thing we're going to see today is our first-class CMake support, which, if you think about CMake, at its core, it's really a scripting language. And so we can parse that scripting language, and we can provide you some project manipulation features that are pretty similar to the stuff that you've seen before with VCXProj and MS Build-based projects. So you can go into the IDE, you can add and remove files, and that's not just adding and removing code files inside your file system, it's also adding references to your CMake list.txt, so it's included in your build. We also provide CMake list.txt IntelliSense, which is suggestions as you're typing in your build configuration files. And if you're new to CMake, this is really handy to help get you started. The last thing that I really want to call out about Visual Studio before we go into a demo is our JSON file to allow you to configure your build configurations for whatever platforms you're targeting. And so what we're going to see today is targeting Windows and Linux with the same project. And you all might be familiar with this project because it's Rollercoaster Tycoon. And so we found an open source reimplementation of Rollercoaster Tycoon. And it's actually a CMake project. And we thought it might be a fun demo to show Visual Studio's developer tools.
Just running into some technical difficulties here, but hopefully you can resolve it. Oh, something's happening. There we go.
There we go.
There we go.
We got it. So I've got the code base open in Visual Studio here. This is Visual Studio 2019. And the way that I actually got here is worth calling out. We're going to ignore that. So if you open Visual Studio 2019, something that's fairly new is our open folder experience. And so a lot of you who've used Visual Studio before might be familiar with opening a VCX proj file or a solution file with multiple projects in it. And so now we offer this feature where you can open a local folder. So you can open a folder that has your code inside, and then it provides a bunch of entry points for configuring your build process. It also provides the entry point for our CMake workload. And so what this means is that when you actually open a folder that has a CMake list.txt in it, we detect that, and we give you a bunch of features that are CMake specific. And so some of these CMake specific features I've called out already. So you can right-click and say, add a new file. You can also have a targets view, because maybe the way that your code is laid out in your folders is not necessarily the most intuitive when you're thinking about a CMake build process. And so you can actually switch and navigate your code using targets view. It's really a personal preference thing. Another thing that we're actually going to give you with the CMake workload is a bunch of features to interact with your CMake cache. So that's open it in the File Explorer. You can delete it. You could open a remote cache that you have already configured on your remote machine. Or you can open your CMake settings, which is what we're going to do right now. So if we go this drop-down right here, this is your active configuration. So all of the IntelliSense and code suggestions and productivity features that you're seeing are running specifically for this platform. So this is my Windows build configuration. And we can do a little bit better than directly editing the JSON. We've got a nice UI for it. If you don't like it, you can go and directly edit the JSON. So this is the Windows configuration. And so since I've already generated the cache for this Windows configuration, you can actually see your CMake variables that we've pulled out of that cache file that CMake has generated for you. And you can edit those variables, and you can really look into what's going on with your build system. So something that Augustin touched on a lot was dependency acquisition as an issue for C++. And so I'm also using Vcpkg, and so I've run Vcpkg on my Windows machine and on my Linux VM to acquire all of the dependencies that I need for this project. So I've got my Windows configuration, and then I've also got my Linux configuration. And let's take a quick look about the main difference between these two. And the main difference is that with the Windows configuration, I have no need to denote a remote machine that I'm targeting, but with my Linux configuration, I do. And so right here, you can see that I've got an SSH connection established to the remote machine that I intend on building and running my programs on. And so the way that I manage this is I open something called the Connection Manager. And so this shows me all of the remote connections that I have added. If I want to add a new one, I can do it through this dialog. And this is not a CMake specific thing. This works for MS Build based projects. This works for CMake projects. It's a Visual Studio utility. So let's make sure that we are on our Windows configuration. And a lot of the productivity features that you're very familiar with Visual Studio C++ tools, they still work when you're writing cross-platform code. So you can do things like peak definition, and it'll show you what's actually going on with that function in case you need a little bit of a reminder. So let's launch the game and see what's going on. So since I've already built this, it's going to be pretty quick, but I am running Rollercoaster Tycoon on a laptop. So it'll take a couple seconds. You guys are missing out on some great circus music because we're not projecting sound.
While that's loading up, just to get a sense of things, can people see the text on the screen in the back, or should we zoom in a little bit? Okay, so we should zoom in a little bit on Visual Studio.
Okay. Sounds good. So this was built with MSVC as I've configured in my x64 debug configuration in my CMake settings.json. So we've got OpenRCT, which is the open source Rollercoaster Tycoon. So we're going to actually create a park. Let's go to Crazy Castle. And we can start building rides. We can have people visit our park. but it seems like it's really cold and rainy and gross, and no one wants to go to a theme park when it's cold and rainy and gross. And so both of us are based in Seattle, so we're pretty used to this, but this kind of looks like non-ideal behavior to me, so I think we should fix this. All right. So clearly, somebody really wanted it to rain as soon as we opened this park. So let's just comment that out.
Should we zoom in first, just to make
yes,
sure?
we can zoom in.
Control plus, I think.
Yeah.
Or it's a different shortcut in Visual Studio. I think there's a drop down there.
There we
can
go.
try that.
All
Okay,
right.
that helps a little
So we've commented out that behavior, and let's go one more time and let's validate our fix. And so something that's interesting about cross-platform code that we really want to call out here is that if you see behavior that you don't want and you implement a fix, you want to test out, you're obviously going to test out on the easiest platform to test out or your main platform, but you also want it to be very easy to switch between platforms so that before you actually check in this fix, you're going to validate that it works on multiple platforms, because it's a lot easier to catch something in the development cycle than it is after CI builds and having bugs filed against you. So that's something that we're going to see is validating on multiple platforms and some of the interesting situations that you can get when you do that. So we do need to rebuild. We're doing an incremental build, so it's not too bad. And again, all of this is powered by CMake. All right, we've got Rollercoaster Tycoon. And so something that I want to call out while this is loading is something that we call remote headers IntelliSense. And that basically means that you saw the drop-down with the active configuration earlier. And so whatever configuration is actually selected in that active configuration drop-down is what your IntelliSense corresponds to. So if you say, I want to go to source on something that's in a Linux header, then if you're on your Linux debug configuration and that's your active configuration, what we do is we pull down your system headers from your remote machine, we cache them locally, and then we can actually navigate to them and show you the code that's going to be executing when you're on your Linux machine. All right, so let's do the same thing we did before and make sure it's not raining anymore. There we go. All right, it's a sunny day, but let's make sure that this fix actually works on Linux as well. So in order to do that, all I have to do is switch my active configuration to a Linux debug configuration, and what's going to have to happen is I'm going to have to regenerate my cache. And so this is all happening over my SSH connection that I added to my remote machine. And the first time that you add a connection to a project or you start a build on a project, it's going to do that, pulling down the headers and then giving you IntelliSense for your project. And so this source synchronization is what you're seeing in the output window right now. And so the only file that actually changed since the last time that I built on this Linux machine is climate.cpp, because we had to fix the weather issue. So that's the only file that's actually getting copied over, which is super nice, because imagine copying the entire repo every time you wanted to make a change. All right, so let's try out this fix on Linux. And so since we've already generated our CMake cache, now we're going to invoke a build, and this is going to be using make files. Oh, I think I mixed up which target I wanted to run. And so I want to run a build first. And so every time we actually invoke a build, it's going to do, rsync is going to do that check to make sure that our source trees are synchronized. All right, so what we're seeing right now is that I have a build error, and this isn't totally unexpected because I'm validating the fact that my fix works on both machines. And so MSVC actually didn't complain about the fact that I had an unused variable, but GCC is showing me this error. And so I'm really happy that I validated this fix on multiple machines. And so I'm getting rid of this variable that I'm not using anymore. And then let's try this again. So since it's a GUI application, I'm going to have to pull up my remote machine. And so something that we're seeing while this is building and loading is that I have Vcpkg for dependency management on my Linux machine. And so I've listed out all of the packages that I've installed with Vcpkg. Some of them are a little bit different than the ones that Augustin was using. But it was just as easy. You clone the Git repository, you run the bootstrapping script, and then you say Vcpkg install whatever libraries you want. And then you can run Vcpkg integrate install, and then VS and VS Code will automatically pick up your dependencies from Vcpkg. All right. It's going to take a couple seconds. Anytime we do demos with VMs, it's always fun. Here we go. So let's make sure that it's not raining inside my Linux machine either. All right, it looks like we've got great weather. So I'm really happy. We validated that my fix will build and run on both platforms that are really important for me to target for my game. All right, let's switch back over. So the key points that I really want to call out about the Visual Studio demo, we'll wait until you can read them along with me. All right, so using Vcpkg for dependency acquisition is really, really a seamless process, especially the integration with Visual Studio. I didn't have to configure anything. I didn't have to point my build process at anything. We automatically detect it, and I've never had an easier time getting C++ libraries. We can leverage the C++ productivity tools that you already know and that you are already familiar with, even if you're writing code for Linux, which I think is pretty incredible. You can also use our first-class CMake support, and so that could include targets view, that could include adding and removing files or targets, and you can use the CMake settings JSON configurations to easily switch platforms and validate that when you make changes, it really works with all of the platforms that are important to you. So a couple other things that we didn't cover. Google.Test and Boost.Test integration for unit testing, ClangTidy and ClangFormat support, and you really don't have to use MSVC and GCC like I was. You can use Clang and LLVM on Windows or Linux. You can mix and match. You can really bring your own tools. Another thing that we didn't cover is the ability to use our WSL native support. And so something that I mentioned when I was talking about WSL earlier was that the Linux command line has visibility into your entire Windows file system. And so we can leverage that. So with the remote scenario, there's really no way of getting around the fact that we do need the sources on your remote machine if you want to build and execute on your remote machine. But with WSL, they're already there because they're visible from the Linux command line tool. So if you want to prototype your code using WSL, that's just another time-saving thing that we can do. The key takeaways from our talk in general, you can easily build Linux apps and you can easily target Linux even if your dev box is not Linux or your preferred tools are not Linux. And you also don't need a full Linux VM and you don't need to set that all up if you just want to try out developing and targeting Linux. CMake is a great choice for cross-platform development. It gives you a lot of autonomy. Modern development environments do already support CMake, including Visual Studio and Visual Studio Code, giving you things like the first class support including project manipulation. And you can manage your library dependencies on Mac OS, Windows, or Linux with Vcpkg super easily.
All right, and we're just running short on time now, but this is the last slide. So we're basically done. This is a list of resources. If you want to learn more, this is going to be predominantly useful if you download the slides afterwards, so you can click through the links and check everything out some more. And yeah, all of this stuff that we demoed today is available today. For the most part, I think, right?
Everything that we demoed today is available today. And another thing that I wanted to call out, everything that we demoed today in Visual Studio is available in Visual Studio Community, which is free.
Yes, that's true. And Visual Studio Code, also free. You can check it out and try it for yourself. All right, and we also have links to the code bases that we were using for those demos as well. Okay. So,
thank you.
Thank you.
I have a couple of questions. Either pick one or just shortly answer both, as you wish. 2 minutes, 2 questions. No pressure.
Okay. you want to go first or should I? So I've got, does Visual Studio Linux build support distributed compilation? Like, there's an example. So the short answer to this is that we support parallel compilations, but we don't have first-class support right now for distributed compilations, but that's something definitely on our radar. The Linux support is fairly new, and we're really racing to figure out what people are prioritizing, and we've got lots of stuff on the backlog, so this is good feedback.
All right, and Mike, the question for me was, how long did it take to set up the Tux VS Code environment? That is a great question. It did not take very long. I think I spent, to get it set up on each environment was probably within a few hours, and most of it was trying to understand the code base and what dependencies it required and going through that documentation just to understand that. Vcpkg helped a lot because it installed almost everything I needed. I think on Linux I had this one graphics related library that I had to install through apt. But otherwise, it was pretty straightforward, and yeah, getting the set up for both of them.
Yeah, it was similar for Rollercoaster Tycoon, where almost all of the dependencies were available through Vcpkg, with a couple exceptions that were available through apt.
Yeah, and it makes your life a lot easier when you install the C++ and the CMake tools extensions in VS Code, that it just lights up a lot of the things that you need, and then you can just get rolling.
The other thing is that with our CMake support, if you are missing a package, then you're going to get that error in your CMake list. You're going to be able to navigate to where in your CMake list that error is coming from. So if it's coming from a find package or a package config call, then you'll be able to see which package you're missing, and it's not an obfuscated process at all.
All right. Well, thank you, everyone. You can catch up with us during the breaks or at the Ask